Welcome to the Earthquake Engineering Module 1, Session 2. In this session, it will be covered with the continental drift theory. Actually, it is put forward by the Alfred Wegener in 1912, which indicates that the large whatever the supercontinent is there, it's existed and then split into the pieces, the existing whatever the fossils and the glacial deposits are the evidence for that. So here Wegener was not able to provide the mechanism for his theory, but the major whatever the mechanism was there, so later it was found, and the details there is a noticeable jigsaw fit between the many continents. Whatever in the previous sessions we have seen the different the continents, for example, between the east coast of the South Africa and the coast of this one South of America, and there exists a matching fit. It suggests that the continents were once assembled together, and the number of whatever the identical fossils are there have been found, and that describes across the southern continents. Fossils of the Mesosaurs dating back around 280 million years ago are found in the South America and Africa. Whatever the plant fossils are, such as the Glossopteris, that is a tree type, have been found in the South America and Africa, even India and Australia. A number of the continents, whatever it is there, showing the evidence of matching the geological sequence with rocks of similar age and types, formation and structures, whatever occurring in different countries. A number of climatic anomalies are discovered, which suggested that the continents must have been in different positions and therefore have experienced the different climate. Whatever the coal which only forms under the wet or a warm condition has been found beneath the Antarctica ice cap, and there is evidence of glaciations in Brazil. Hence, the continents were once joined, therefore they found and they have moved apart over a time period. And whatever the Wegener proposed a mechanism for continental drift, the pushing of continents by the gravitational forces that derived from the sun and moon, similar to the tides which you can see it in the oceans. And whatever this figure is there, so which exactly it presents the jigsaw matching and similar fossils that is presence in different the continents. And this whatever the figure itself will show the evidence that this the how this the theory which we can say is as a continental drift theory, and as the time period the passes, and here the whatever the different the pieces of the whatever the continents are there, so they have moved to the different places what we can see it in the present scenario. Now here next whatever the point is there as far as the earthquakes are concerned, based on the whatever the continental drift theory. So now we'll see it the elastic rebound theory, how exactly the earthquakes are going to happen. And here you can see it in the figure that whatever the sudden slip is there, sudden slip as a fault that causes the earthquake is nothing but the violent shaking of the earth, during the which large elastic strain energy released and spreads out in the form of seismic waves, and that travel through the body and along the surface of the earth. And after the earthquake is over, the whatever the process of the strain is there, process of the strain build up as it is modified interface between the tectonic plates start over, and all you can see it in the figure that earth, whatever the scientists are there, and it's said that the elastic rebound theory, which the collection of material points at the fault over which the slip occurs usually the constitutes at along the three-dimensional volume, which it long dimensions often running into the tens of the kilometer in case of the significant earthquake. And now here you can see it from the figure that how exactly the earthquakes are going to happen based on this elastic ribbon theory is that this whatever the two the figures are there, so the base is reference with respect to time in terms of years, and the whatever the vertical ordinates is there, elastic stress how it is going to develop and how the cumulative slip is going to happen. You can see is that as the time goes on, the whatever the elastic stresses are going to be come to up to a certain strength, and when the elastic limit is get over, and suddenly there is a slip of the whatever the plates are there, and suddenly there is a release of the energy, and that is the cause of the earthquake. And again the elastic stress will be gradually moved to 2 years together, and again when it is exceeding its elastic limit, and suddenly there is a jerk, that is a slip is going to take place, and again that is a point A, which is the cause of the earthquake. And as the time pass, so the energy is going to build up, again the energy is going to release. So this is a continuous process, it is a continuous process, and this particular the theory which we can say it as a elastic rebound theory. And now here whatever the elastic rebound theory and the plate tectonic theory, all those things are there, then how this the faults are going to be the active as far as the earthquake cause is concerned. And most of the earthquake in the world occurs along the boundaries of the whatever the tectonic plates are there, as which has been already called it as a intraplate engineering in intraplate earthquake. So here actually the earthquakes are generally originate on the planes of the weakened parts of the earth crust, that is called as a faults. And faults are formed when the two the whatever the crustal rocks beds slip relative to each other. Faults are classified according to the directions of the relative slippage. A number of the earthquakes also occur within the plate itself, but away from the plate boundaries. And these are nothing but called as the intraplate earthquake. And here the tectonic plates are the breaks in between in the types of the earthquakes, and the slip generated at the fault during the earthquake is along both horizontal directions, and that one is called as a dip slip. You can see it in the figure, how this dip slip is there. And another one is the lateral direction, another one is lateral, one is vertical, another one is the lateral directions. In the lateral directions whatever it is there, so you can see it as a the strike slip with one of them dominating sometimes. So this is all about the faults of there, types of faults of there. Now now coming to the earthquakes are concerned. So here in this figure you can see that how these earthquakes are originated, and how this energy is going to transfer in the form of the seismic waves. So that is nothing but the general depictions of earthquake rupture scenario what we can see. And now actually there are the number of causes of the earthquakes are there. whatever the earthquakes are there, it causes number of the causes, and mainly they are natural. And already in the previous sessions we have noticed that there some of are there of man-made, or some of are they are the natural. And the classifications of the causes are the tectonic earthquake, volcanic earthquake, rock falls or collapse of cavity, microseism, and then explosions, then reservoir induced earthquake, mining induced earthquake, and cultural noise, that is based on the industry or traffic. So in general, the earthquake is nothing but the vibrations of the earth's surface that caused by the waves coming from the sources, that is the disturbances inside the earth. Most of the earthquake of the engineering significance are of tectonic origin, and that is caused by the slip along the geological fault. And actually the whatever the characteristics of the earthquakes are there, so they are depending upon the stress drop during the slip. And second one is the total fault displacement. The third one is the size of slipped area, and the fourth one is the roughness of the slipping process. Fifth one is the fault shape. It may be a normal fault, or it may be reverse fault, or it may be strike slip type of fault. And it sixth one is the proximity of the slipped area to the ground surface and the soil conditions. So these are the some of the characteristics of the earthquake, how they depends. Now coming to the classifications of the earthquakes are concerned. So earthquakes can be broadly classified into the following subclasses. The first one is based on the focal depth, based on the magnitude, based on the origin, based on the location, and based on the epicentral distance. So now let us see it one by one. So here, as far as the focal, based on the focal depth is concerned, so it will be called as a shallow focus earthquake where the focal depth is less than 70 kilometer. And intermediate focus, the whatever the earthquakes are there, where the focal depth is in the range of 70 kilometer to 300 kilometer. And deep earth focus earthquake, what we can call it, is when the focal depth is more than 300 kilometers. And now next classification is based on the magnitude. So here, whatever the micro earthquakes are there, where the magnitude is less than 3. So anyway, so in the next we'll see that the meaning of the magnitude, all those things. Right now this magnitude is represented by the M, and it is ranging from 0 to 10. And here you can see that the intermediate earthquakes where the M is ranged from 3 to 5. And moderate earthquake, the whatever the magnitude M is range from 5 to 6. Strong earthquake, the magnitude is varies from 6 to 7. Major earthquake, here the magnitude is range from 7 to 8. And great earthquakes where the M value, magnitude value, is more than 8. Next classifications is based on the origin. So here it may be the classifications of the origin is the first one is the tectonic earthquake, then plutonic earthquake, it may be explosions, or it may be a collapse of earthquakes, or it may be due to the volcanic earthquakes, or it may be reservoir induced earthquake. So like that, the origin, based on the origin, what we can classify. Now based on the location, so here there are two types of the locational classifications we can make. So one is intraplate, another one intraplate and intraplate earthquake. So as far as the intraplate are concerned, it may be convergent boundaries, or it may be divergent boundaries, or it may be transfer plane boundaries are concerned. That is how this the plates, the tectonic plates movements are there. Next is the intraplate. Is again, it may be classified as a dip slip fault, or it may be the strike slip. So how this the faults are there, according to that the classifications are made. Then the last, whatever the classification is there, based on the epicentral distance. So whatever the epicenter is there, so if it is in the range of 4 kilometer, then we can call it as a local shock. And near shock if it is between the 4 to 10 kilometer range, and distant shock if it is 10 to 20 kilometer range, and telescopic type of shock when it is more than 20 kilometers. So these are the some of the thing how the classifications of the earthquakes are made. Now coming to the major past earthquakes and their consequences, what we can see it as far as some past earthquakes in India. So here look into the chart starting from 1819 to the 2004. So in this chart it shows that a number of significant earthquakes have occurred in and around India. Before that also 1819, but as far as the records are concerned, so only the record has been started noting after 1819 only. So that's why you can see the details of that one. So in and around over the past century, some of those occurred in populated and urban areas and hence caused the great damage. And many went unnoticed as they were occurred deep under the earth's surface or in relatively uninhabited places. Some of the damaging and recent earthquakes, which we can see it in the table. Most of the earthquakes are occurred along the Himalayan plate boundaries. That is nothing but the intraplate earthquakes they are classified as. But a number of the other earthquakes are also occurred in the peninsular region, and they are called as a intraplate earthquakes. And you can see that the earthquakes may happen anywhere, anytime. So can that there is no consistency as far as the timing is concerned, and there is no consistency as far as the place is concerned. Also there is no the repetitions or occurrences after certain years like that. There is no informations like that. And even if you can see the magnitude is also going to vary, and the whatever the intensity part is also there, that is also going to vary. And based on the magnitude or intensity, the whatever the depth factors or life lost during the earthquakes, that one is also going to vary from time to time. So it is totally the very uncertainties are exist as far as the earthquakes, whatever the past, whatever the record, what we can see it. Now let us coming to the seismic waves. It's a very interesting to see that the whatever the earthquake vibrations are there, so they originate from the point of initiations of the rupture, and whatever it is propagates in all directions. And these vibrations travel through the rock in the form of elastic waves. There are major the two types of the waves are there. So the first whatever the waves is there, it's a primary waves, that is a P waves you can call that, and second one is the secondary waves. And these are nothing but the body waves. And another type of the waves are surface waves, and these surface waves are of Rallies, or sometimes it may be low waves. So like that the classifications of the important classifications of the whatever the waves are there. Now as far as the body waves are concerned, so they travel through the body of the earth. And here the P or a primary waves are the fastest waves that travels through the solids, liquids, or even the gases. And these are the compressible type of the waves, and material movement is in the same direction as the wave moment. So other one is the S waves, or secondary waves, or sometimes it is called as shear waves, are the slower than the P waves, okay, primary waves, and they travel through the solid only. The whatever the material moment is there, it's perpendicular to the wave moment. So what we can see it between the P waves and S waves, P waves will be push and pull like that, the extension and compression, and the S waves will be side to side as well as up and down, so while taking the directions of the moment. And next the two types are surface waves. that is low waves or the Rallies waves. So these surface waves are produced at the Earth's surfaces. They travel just below or along the ground surface. They are slower than the body waves, and they cause rolling and side to side movement. You can see that side to side movement are sometimes rolling, so elliptical in vertical direction, so especially causing the which are damage to the buildings. The surface waves in fact will cause the damage to the buildings, and different waves travel at a different speed, and they arrive at a different instant of time at a places. So that what we can see it from these waves. So now as far as the primary waves are concerned, so here these waves are pull push waves, and they are the longitudinal waves and compressional waves. So like that the waves will going to propagate, and these waves propagate by longitudinal or a compressive action, which mean that the ground is alternatively compressed and dilated in the directions of the propagations. Actually, this primary P waves are fastest among the seismic waves and just travel as fast as 8 to 13 kilometer per second. Therefore, when the earthquake occurs, these are the first waves to reach any seismic station, and hence the first to be recorded. Whatever the P waves resemble sound waves because these are two compressional or a longitudinal waves in nature. Hence, the particles vibrate to and fro in the directions of propagation, that is longitudinal this particle motion. So these waves are capable of traveling through solids, liquids, and gases. Whatever the P waves are there, they are propagate radial to the source of the energy released, and the velocity is expressed by this equation, that is a Vp is equal to square root of E by rho into 1 minus nu divided by 1 plus nu plus 1 minus 2 nu. So whatever this E is there in this, it's Young's modulus, and nu is the Poisson's ratio, usually around 0.25, and the whatever the rho is there, so which is nothing but the density. Now coming to the secondary waves. So these waves are also called as shear waves or a secondary waves or a transfer waves, like that. And compared to the P waves, these waves are very relatively slow, and these are transfers or shear waves, which mean that the ground is displaced perpendicular to the directions of propagations. In nature, these are like light waves, that is, the waves move perpendicular to the directions of propagation. Hence, the transverse particles motion is characteristic of these waves. These waves are capable of traveling only through solids. If whatever the particle motion is parallel to prominent planes in the medium, they shall called as SH waves. On the other hand, if the particle motion is in vertical, they are called as a SV, that is secondary vertical waves. So like that they call. The shear waves, whatever the velocity is there, so that is a Vs is given by square root of E divided by 2 rho into 1 plus nu, or nothing but is equal to square root of G by rho, where G is the shear modulus and is given by E divided by 2 into 1 plus nu. And they travel at the rate of 5 to 7 kilometer per second. For this reason, so these waves are always recorded after the P waves in the seismic station. Now let us see about the surface waves. So these surface waves, when the vibration waves energy is propagated near the surface of the earth rather than the deep in the interior, two other types of the waves known as the Rallies and the low waves can be identified. These are called surface waves because their journey is confined to the surface layer of the earth only. The surface waves travel through the earth crust and does not propagate into the interior of the earth like primary and secondary wave, just like a P and S waves. The surface waves are slowest among the seismic waves. Therefore, these are the last to be recorded in the seismic station at the time of occurrence of the earthquake. So they travel at the rate of 4 to 5 km per second, and the complex and elliptical this particle motion is characteristic of these waves, and these waves are capable of traveling through the solids and liquids. They are complex in nature and are said to be of two names, that is the Rallies waves and this love waves. This particularly the first, whatever the Rallies waves is there. So they are waves are in tension compression waves, similar to the P waves, except that the amplitude diminishes with the distance below the surface of the ground. Then similarly, the love waves are the counterpart of S waves, that is S body waves, and they are of shear waves, and that diminishes rapidly with the distance below the surface. The whatever the damage and destruction associated with the earthquake can be mainly attributed to the surface waves. So surface waves will really cause for the destructions to, whenever the earthquakes are going to happen. So this damage potential and strength of the surface waves reduce with the increase in the depth of the earthquakes are concerned. So this is all about the seismic waves are concerned.